We're going to start with a question that sounds innocent. What happened before the Big Bang? People ask it the way they ask what's behind a door. Like the universe is a room, and the Big Bang is just the moment someone turned on the lights. And that picture feels so natural that we don't even notice we're smuggling something in. We're smuggling in time as if time were already sitting there, waiting like an empty stage. But if the Big Bang is what we think it is, that instinct might be illegal, because E before isn't just a word, it's a structure. It assumes a clock. It assumes an ordering. It assumes a background where events line up politely. And here is the uncomfortable possibility. The Big Bang wasn't an event inside time. It may be where U before stops making sense. If that's true, then the problem isn't that we don't know the answer yet. The problem is that we might be asking a question the universe refuses to interpret. So instead of demanding a story that feels human, let's ask something more careful. What kind of reality would make C before the beginning a contradiction? Let's try to picture what that question is really asking. Imagine time as you normally do, a line past behind you, future ahead. Events laid out like beads on a string. One thing happens, then another, then another. Now imagine you start walking backward along that line. You pass familiar landmarks. The formation of the Earth, the birth of the sun, the first atoms, the first light. You keep going. Everything gets hotter, denser, more compressed. Space itself seems to be shrinking around you. Distances collapse. The universe becomes smaller, younger, more crowded. So far, nothing feels strange. This is the story you've heard before. Now keep going. Eventually, the landmarks disappear. Atoms no longer exist. Particles stop behaving like objects. Even the idea of equidistance becomes unreliable. Space isn't something things are in anymore. It is something that's being squeezed out of existence, and still your intuition insists on one more step. What's next? What happens just before that? Here is where the trouble begins. Because to take another step backward, you need time to still be there. You need a clock that keeps ticking. You need a direction labeled earlier that still means something. But what if that direction is exactly what's disappearing? What if time isn't a road you're walking on, but part of the terrain that's collapsing as you approach this limit? Picture the North Pole. You can walk north from anywhere on Earth. Step by step it makes sense. But once you reach the pole, something strange happens. North it doesn't point anywhere anymore. Not because there's something blocking you, but because the concept itself has run out of meaning. Asking what's north of the North Pole isn't forbidden. It's empty. The Big Bang may be like that. Not a moment you can step past. Not a hidden scene waiting behind a curtain, but a boundary where the direction you've been using earlier stops pointing anywhere at all. And notice what this does to the original question. If time itself is part of the universe, then asking what happened before the universe is like asking where a map is located before space exists. The question isn't unanswered. It's undefined. That's the unsettling part. Not that physics hasn't solved the mystery yet, but that the mystery may be created by the way your mind insists on organizing reality. And once you see that, the Big Bang starts to look less like a beginning and more like the edge of a concept you were never allowed to push past. This is usually where intuition tries to rescue itself. It looks for something solid, something familiar, something that sounds like an explanation. Maybe the Big Bang was an explosion. That feels right. Explosions have beginnings. They happen at a place. They throw things outward into space. You can imagine what came before them. But the moment you take that picture seriously, it falls apart. An explosion needs space to explode into. It needs time ticking before it happens. It needs a background where events are already ordered, and the Big Bang doesn't give you any of that. So maybe it wasn't an explosion, but a creation event, a moment when everything suddenly appeared. Again, that feels satisfying until you notice you're still sneaking time in through the back door. Suddenly assumes a clock. A period assumes a before and an after. You're still trying to tell a story the universe may not be telling. At this point, many people quietly say, well, physics just hasn't figured it out yet, and that sounds reasonable. But notice what's really happening. Every explanation you reach for assumes the same thing, that time is already there, waiting patiently for the universe to show up inside it. That assumption works everywhere else in your life. It works so well that you rarely notice it's even there. But here, it breaks. Because if time itself is part of the universe, if it's something that comes with spacetime, then there is no external clock watching the Big Bang happen. There is no earlier outside of it. And that's where intuition finally gives up, not because the math is too hard, not because the idea is abstract, but because the picture you've been relying on, events unfolding on a timeline, no longer applies. The Big Bang doesn't fit inside your idea of time. It challenges the idea itself, and if that feels deeply uncomfortable, that's not a failure. That's the signal that you've reached the edge of the old model, which means if there's any understanding left to be found, it has to start somewhere entirely different. So let's rebuild the picture, but this time without smuggling old assumptions back in. Instead of asking what happened, let's ask something more careful. What does physics actually mean when it talks about the Big Bang? Strip away the metaphors. No explosions, no creation scenes, no cosmic fireworks. At its core, the Big Bang is not a story about things appearing. It's a statement about relationships. Distances between things were smaller. Temperatures were higher. The rules connecting space, time, energy, and matter behaved differently. That's it. The equations don't describe a moment when the universe turned on. They describe how the universe behaves as you trace its structure backward until the structure itself stops cooperating. And that's the key shift. Physics doesn't say, this is where everything began. It says, this is where our description stops working. Those two sound similar. They're not. Imagine drawing a map. As long as the terrain is smooth, your map works. Roads connect, distances make sense, directions point somewhere. But as you approach a cliff, the map doesn't tell you what's below. Not because there's something mysterious hiding there, but because the map was never designed to represent a sheer drop. The Big Bang is that cliff. It's the place where our current way of describing reality using smooth space-time, continuous time, and well-behaved geometry runs out of road. And now comes the mid-peak realization, the one that usually snaps something loose. The Big Bang wasn't the beginning of the universe. It was the beginning of what beginning even means. Before the Big Bang, asking what happened may be as meaningless as asking what a shadow weighs. The grammar of the question doesn't apply. Time isn't an external parameter counting events from the outside. It's part of the system, woven into space-time itself. So when space-time reaches this boundary, time doesn't point past it. It ends not as a dramatic final, but as a coordinate that no longer exists. This is why physicists say the Big Bang is a boundary, not an event. Boundaries don't have wood before. They have edges. And this reframes everything that feels uncomfortable about the idea. Why can't we talk about what happened before the Big Bang? Not because it's hidden, not because it's secret, because before may not be a valid direction there at all. Now push this one step further. If time is part of the universe, then the universe doesn't need a starting gun. It doesn't need a moment when someone pressed play. It only needs consistent rules relating change, structure, and causality, rules that hold everywhere they apply. The Big Bang marks the limit of those rules as we currently understand them, and that's not failure. That's honesty. Physics isn't embarrassed by boundaries. It doesn't promise more than it can justify. When the equations stop making sense, physicists don't invent a comforting story, they stop. This is deeply unsatisfying for the human mind. We want origins, we want causes, we want stories with clear first chapters, but the universe doesn't seem obligated to provide them. Instead, it offers structure without narrative, relationships without intention, laws without motivation. And this leads to the quiet but devastating conclusion. The Big Bang doesn't answer the question, why is there something rather than nothing? It doesn't even try. It answers a different question entirely. How far back can meaningful description go? And right now, that answer is this far: no explosion. No first moment ticking on a clock, no cosmic birth certificate. Just a boundary where our language about time, cause and sequence stops being well-defined. Once you accept that, the Big Bang stops feeling like a missing explanation. It starts feeling like a warning label. A reminder that some questions don't fail because they're hard. They fail because they assume a universe that doesn't exist. This isn't just a philosophical maneuver. It shows up directly in what we actually observe. When astronomers look out into the universe, they don't see evidence of a past explosion throwing matter into empty space. They see something subtler. Every direction looks roughly the same. Galaxies aren't moving through space away from a center. Space itself is stretching between them. And the further back we look, the younger the universe appears, hotter, denser, more uniform. Eventually, we reach a point where our measurements still work, but our explanations don't. The radiation left behind from that early era is real. We can measure it, we can map it, we can build technology around it. But when we try to push the equations past that boundary, they stop agreeing with each other. Not because the universe becomes mysterious, but because the assumptions we rely on stop being valid. So the Big Bang isn't a guess about what happened long ago. It's a label we use for the edge where observation remains solid but description no longer does. That edge isn't speculative, it's measured. And it's telling us very calmly how far our current ideas are allowed to reach. Once you really sit with this, the discomfort doesn't come from ignorance. It comes from clarity, because the Big Bang isn't hiding a secret origin story from us. It isn't waiting for a better theory to reveal what really happened before. It's telling us something more unsettling, that the universe may not be organized around beginnings at all. Beginnings are how we think. They're how biological minds make sense of change. But nature doesn't need a first chapter. It only needs rules that hold wherever they apply. And when those rules stop applying, nature doesn't fill in the gap with meaning. It leaves it blank. This is why the question feels so unsatisfying. We're not running into a wall of missing information. We're running into a boundary where our habits of explanation no longer work. The universe isn't refusing to answer. It's refusing to translate the question. And that shifts something important. The Big Bang stops being a mystery to solve. It becomes a reminder that reality doesn't have to match the way a human story is told. It only has to be consistent with itself. The strange thing is, this doesn't change how your day feels. Time still seems to flow. Causes still come before effects. The universe behaves politely enough for life to exist. But the next time you hear someone ask what came before the Big Bang, pause for a moment. Ask whether our before is doing more work than it's allowed to. Some limits aren't gaps in our knowledge waiting to be filled. They're signs that we've reached the edge of a concept we carried too far. An understanding that doesn't make the universe smaller. It makes it more honest.